and sharing the screen. And again, as I was saying it before everybody was in class, if anybody got a late penalty on an assignment because my labs was not behaving the last couple days, please let me know and I will take away that late penalty. Today's March 31st. Hopefully everybody remembers, knows that there are not classes on Friday, so it's going to be a long weekend. And oh my gosh, I didn't put in a quiz for you guys this weekend. Can you go a quiz without a weekend? Is that going to be problematic?
I think we can make do.
Okay. All right. Then homework 2.4 is due today. If I remember correctly, that's the homework that deals with more on slope. It deals with the relationship between parallel and perpendicular lines. Homework 2.8 is due on the 5th, which is Monday. That's the homework that deals with distance, midpoint, and what we're looking at today, circles. Homework 3.1 deals with parabolas. That'll be the last homework, the last thing that we're talking about. So problem set 3 will be due on the 9th. And right now, test 3 is tentatively going to be the 9th, which is Friday. We'll see how things go by the beginning of next week, whether the test will be from Wednesday till Friday, close Friday, or whether the test will be open Friday and be due Monday. In general, does anybody have a preference? Is it easier for you folks if the test is available over the weekend? Could everybody please mute yourselves?
You live in the West. You niggas is bums and y'all gay.
Could you guys please mute yourself? Thank you.
I'm so sorry about that.
Okay, just be careful. So test 3, it will be coming up the end of next week. Does it make it easier for you folks to have the test available over the weekend? Or do you rather have it midweek?
The weekend's probably fine.
The weekends, so it'll probably be opening on the
Like Friday to Sunday.
Friday, yeah. So
That's
because the
fine.
9th is that Friday. So now before we start picking up where we left off last class, is there anybody who has
Can we do the homework
a
overview?
question on the homework?
Yes.
All right, let's look at that. Look at how fast, well, I spoke too soon. Look at how fast my labs is coming up. What homework assignment, what homework question are we looking at?
Today, number 5.
On which homework? The one that's
The one today.
okay. Use the given conditions to write the equation of a line in point slope form and in general form. And we want a line passing through a given point that's parallel to a given equation. Because they specifically asked for this one in point slope form, I would not use the shortcut to do this one, but rather I would go through and first of all, if I know that my line is going to be parallel to 5x minus 8y minus 3 equals 0. To be parallel, the first thing I'm going to do is I'm going to find the slope of that line. And to find the slope of the line, I'm going to solve for y. And so adding 8y to both sides, I get 5x minus 3 is equal to 8y. And dividing, I get 5/8 x minus 3/8 is equal to y. And so my slope is 5/8. Does that make sense?
Yes.
Now that I have the slope, I'm going to use the point slope formula. And so again, the point slope formula is y minus the y value of my point is equal to the slope times x minus the x value of my point. And if my point is -6, that would give me y minus 6. Could everybody please mute themselves if you're not talking? Thank you. Is equal to 5/8 times x minus a -2 would be x plus 2. And so that's the line in point slope form. Then to put it in general form, I would distribute y minus 6 equals 5/8 x plus 10/8. Then I'd probably get rid of the fractions by multiplying both sides by 8. Getting 8y minus 48 is equal to 5x plus 10. And then making one side 0, subtracting the 8y and adding the 48 to both sides would give me 0 equals 5x minus 8y plus 58. And now I'm going to do a quick check. We had said that if it was parallel, the x and y coefficients would be the same. Yay, they are. What changes is my constant term. So let's see, if I take 5 times -2 minus 8 times -6, I do get that 58, so it does indeed work. Better?
Yes.
What you need to remember is for the words parallel and perpendicular, the first thing that you need is that slope. Once you have that slope, if you've given a point, you're just going to substitute in for point slope form. And then for general form, distribute, clear whatever fractions you have and make one side 0. Again, general form, if it's parallel, the x and y coefficient should be the same. If it's perpendicular, the x and y coefficient should be flipped. And you should have the opposite operation. One will be addition and the other will be subtraction. Again, that's for perpendicular. For parallel, they're the same. Can I erase this?
Yeah.
Does anybody have, and are there any other questions on this homework or any other homework?
Can we do maybe one more?
Yep, which one?
About 10. Number 10.
Yep, I'm trying to admit somebody from the waiting room, and what I have to do is take my finger and no longer make it a mouse. Pen. I always forget, in order to write in Zoom, I need to change my finger to a pen, and I always forget I have to turn it back into the mouse. Okay, the graph of the line passing through the given point that's perpendicular to the line whose equation is x equals 11. Well, actually, this question is chock full of shortcuts, because usually when we see the idea of perpendicular lines, we again think slopes, but instead of being equal, the slope is the negative reciprocal. But what happens is I look at this line, and this line's different. It's x equals 11. And if the x value is always the same, remember that means I've got a vertical line. And so I'm not going to worry about slope. In order to be perpendicular, it's going to be a horizontal line. If a vertical line has an equation x equals, a horizontal line is going to have the equation y equals. So now the only concern we have is, what does y equal? And in order to answer that question, if it's got to go through this point, doesn't y have to equal the y value of that point? And so here, perpendicular to a vertical line is a horizontal line. It will be y equals, and y has to equal whatever y value is of the point that's on the line. So that one's not very much work at all, but a bit of thinking. Remembering that if it's just x equals, it's a vertical line. To be perpendicular, it's a horizontal line. If x equals is vertical, y equals is horizontal. That's a fun one.
So is the next one like kind of similar though?
What do you mean, the next question?
Yeah.
I don't know. This homework was picked out years ago. I don't remember. Well, this one, it's going to be perpendicular to a line that has an x-intercept of 4 and a y-intercept of -8. Here, we do need to be perpendicular. We do need to find the slope. And to find the slope of this line, what you have to remember is that if the x-intercept is 4, it goes to the point 4, 0. And if the y-intercept is -8, it goes to the point 0, -8. And so now this time you're going to use those points to find the slope. And then for perpendicular, remember that the slope is negative reciprocal. And then use your point slope formula.
Nice.
Okay.
Yep.
Does anybody else have any other questions on any of these homeworks? If not, can I go back to where we left off on Monday? On Monday, we had looked at the distance between 2 points being the square root of the difference in the x values squared plus the difference in the y values squared, where x1, y1, and x2, y2 are points, the endpoints. And then we use that to say, well, the equation of a circle with a given center, and I think we had our center be a point HK, and our radius be some number R, is given by squaring that. X minus the point we want is H squared, plus Y minus the point we want is a Y value of K squared. And because we got rid of the square root and distance formula, we've got to square the other side and get R squared. And we looked at this as the general equation of a circle. And so we chose different numbers for our points and different numbers for our radii, and we were able to write the equations of circles. And then we looked at a whole bunch of equations to find the center and the radius of, and we had something like x minus 5 squared plus y plus 3 squared equals 33. And comparing it to the general form, does everybody remember the center? Well, the x value of the center is what's being subtracted from the x. So that'll be 5. The y value is what's being subtracted from the y. Because that's a positive, we were subtracting a -3. And then the radius, well, if this number is the radius squared, the radius is the square root of that number. And the square root of 33 doesn't simplify. And so we'd stop there. Does everybody remember leaving off their last class? And then just as we ran out of time, I posed another question where I asked you to find the center and radius of the circle. And we had something like x squared plus y squared minus 10x plus 6y minus 30 equals 0. And we said that this was an example of an equation in general form. We said we know it's a circle. because both x and y are squared. And they have the same coefficients. We said that that other formula that we had a center radius form, general form for a circle, is x squared plus y squared plus dx plus ey plus f equals 0. And we had said to find the center and the radius, we'd have to complete the square. In both x and y. To get center radius form. And I think we had just finished writing a statement somewhat like that when I looked at the clock and realized that we didn't have time to finish the problem. So if everybody can wrap their minds around all of that, which was what we had said, I believe, last class, let's go back to our example, which was x squared plus y squared minus 10x plus 6y minus 30 equals 0. And am I correct in assuming that you guys like it as we go through an example if I write out the cookbook steps? First thing we want to do is we want to isolate the constant. We want to take that plain old number and get it alone on one side of the equal sign. In order to do that, I'll add 30 to both sides. And so that'll give me x squared plus y squared minus 10x plus 6y equals 30. Because I'm usually a little lazy, I usually do the first two steps, two things all at once, but we'll separate them so that everybody's sure to see the importance of both. The next thing that I want to do is use the commutative property to rearrange the terms so that the x's are together and the y's are together. Usually when I do this, I kind of leave a gaping hole in the middle. But you see, I want to just swap these two to get x squared minus 10x. I'm going to leave a little bit of space, plus y squared plus 6y. I'm going to leave a little bit of space, equals 30. Everybody all right so far? Then what we're going to do next is add constant or constants, usually it's more than one, to both sides to create two perfect square trinomials. And so here's where we have to do a little bit of remembering from what we did solving quadratic equations before we got to that quadratic formula. Remember, we were looking for what number in here would make it a perfect square trinomial. And you remember, in order to reach that decision, we looked at the middle term. We took that coefficient, divided it by 2, and squared it. And so -10 divided by 2 is -5. Squared is 25. So remember, we wanted to add 25. And it's an equation. If I add 25 to one side, I have to add 25 to the other. So I did it for the x. Now I want to do that same thing for the y. And so for the y, in order to fill in this space, I'm going to look at that 6. I'm going to take that 6 divided by 2 and square it. 6 divided by 2 is 3. Squared is 9. And so here I'm going to add 9. Doing that, I get x squared minus 10x plus 25 plus y squared plus 6y plus 9 equals 64. And so we're going to express that as that binomial squared. So that'll give me x minus 5 quantity squared. Plus this would give me y plus 3 quantity squared equals 64.
Excuse me, ma'am. Please, where did you get the 25 and the 9 from?
Okay. Remember way back when we were looking at solving an equation by completing the square, if I have x squared minus 10x, I wanted to figure out what went there. Remember, in order to make that, decide that, I took this coefficient, divided it by 2, and squared it. So that would give me -5 squared, which would be 25. And so if I put 25 in there, what I get is x squared minus 10x plus 25. And if I went to factor that, it would give me my x minus 5 squared. And so the 25 came from taking half of that 10 and squaring it.
Okay, I'm sorry.
And so over here, we do that for x, and we have to also do those steps for y. So for y, I'm taking that coefficient 6, dividing it by 2 and squaring it, which would give me 3 squared or 9. And so that's where that 9 comes from also.
Okay, I understand. Thank you very much.
Okay, thank you for asking. And now it's in center radius form. And so I can look at this and say, okay, all right, my center is, I'm subtracting 5 from x. I'm subtracting -3 from y. My radius squared is 64. So my radius is 8. And we've answered the question. Shall we try a couple more? Let's do one more together and then have you folks try one on your own. So next example together, let's find the center and radius of, let's say I have x squared plus y squared plus 16x minus 12y plus 9 equals 0. Again, the first thing we want to do is we want to take that constant term, that plain old number, and get it on the other side, get it alone. To do that, I'll subtract 9 from both sides. Gives me x squared plus y squared plus 16x minus 12y equals -9. And initially, when that other side is negative, it's a little bit unsettling, but we don't want to pass judgment on the sign of that number until we've completed the square. Before we complete the square, we want to take these two and commute them, interchange them. So I get x squared plus 16x plus y squared minus 12y equals -9. Is everybody comfortable so far? And I left those holes, those spaces, because I know that I have to put something in there to get a perfect square trinomial. If this is 16, what do I have to add here? Remember, we're going to take that 16 divided by 2 and square it. 16 divided by 2 is 8. Squared is 64. So I'm going to add 64. But remember, it's an equation. What I add to one side, I need to add to the other. And that was so much fun. I get to do it a second time. This time, though, for y. And so what would I have to add to make the y terms a perfect square trinomial? 6 squared. Did you say 6 or did you say 36? Six squared is 36, and I'll go on the assumption that you said 36, and it was my old lady ears that didn't hear the 30. So now we've got x squared plus 16x plus 64, which would be x plus 8 squared. Plus, we have y squared minus 12y plus 36, which would be y minus 6 squared. And over here, 64 plus 36 is 100, minus 9 is 91. And so, now that it's in this form, my center, well, if that's a plus 8, I must have been subtracting -8. That's a minus 6. We're subtracting 6 from the y. And remember, you want to make sure they're in XY order. And then the radius, well, if the radius squared is 91, wouldn't the radius be the square root of 91? What do you think, folks? Not hearing any concerns. I'm gonna,
But 91 is not perfect.
so we're just gonna leave it as the square root of 91.
Oh, okay.
I don't think anything divides 91 evenly that's gonna give me a perfect square. And so we're just going to leave it be. Radius is the square root of 91. Mighty fine number. So one more. Let's find the center and radius of, and this time I'm going to have x squared plus 8x. Oh, I'm sorry. That was wrong. X squared plus y squared plus 8x minus 4y minus 7 equals 0. And I'm going to be quiet for a few minutes and ask you folks to get this in that center radius form by completing both squares. Then tell me what you get. Stephanie, are you in class?
Yeah,
Okay, all right. I didn't see your emails because when I have Zoom open, I can't see my email. And I just wanted to make sure. Okay, thanks. How are you folks doing? Are we still working or are we in that go over place?
I got -4 +2, and I got a radius of square root 27.
Beautiful. I got a center of -4, 2. And I got a radius of the square root of 27. But realize that 27 can be simplified. 27 is 9 times 3, and the square root of 9 is 3. So simplified, it's 3 square roots of 3, 3 radical 3. And so just when you're doing these, if you type in the radius is the square root of 27, my labs will tell you, wait a minute, you need to simplify that. They'll say your answer's right, but it's not in the right form, if they want it in simplest radical form.
Okay.
Great. How did everybody else do? Are we all right with this? Any concerns or questions, please ask now. If not, circles are one type of second degree equation. There are several. If you go back, if you go on and take Math 111, you'll find all sorts of second degree equations that you need to be able to graph. This course, we're only going to look at circles. And then the other thing is the graph of a quadratic function. And a quadratic function, quadratic equation was ax squared plus bx plus c, and with an equation we set that equal to 0. With a function, we're going to say that that's f of x. Remember, f of x is just a fancy way of saying y equals ax squared plus bx plus c. And in order to be a quadratic function, a, b, and c are going to be real numbers. And in order to be quadratic, we need that x squared. So we know that a cannot be 0. And this is a second degree function. When we graph this, we're going to get a parabola, so that the graph is a parabola. A parabola will have as a general shape something like this. When I look at a parabola, there's one point where it changes direction, that turning point is referred to as the vertex. And obviously, I can't draw. That's why I teach math instead of art. But through that turning point, there should be a line that's called the axis of symmetry. And it's that idea that this graph should be symmetric. If I fold it along that line, it should fall right on itself. The two sides should match up. We'll find parabolas can open upward like that, or it could also be turned upside down and open downward. Mr. Blitzer, in the book, has 3 different approaches to graphing a parabola. This course, we're only going to look at 2 of the 3. if you take Math 111, you'll look at that third. But the first method of graphing is by looking at the equation in vertex form. And before we look at the equation in vertex form, we need to be able to wrap our minds around the idea that parabolas can be viewed as transformations of a general parabola which is y equals x squared. And so I think we might have talked a little bit about this idea of transformations at the beginning of the semester when we were first looking at graphing, but I'd like to go through and reiterate it again, because I think in looking at it again, it helps us understand this version of the equation of a parabola. And so first, let's sketch f of x equals x squared, our general parabola. And remember that f of x is just a fancy way of writing y equals x squared. Let's graph these by making tables of values. For x, I'm going to start with 2, 1, 0, -1, -2. I'm going to substitute into y equals x squared to get my y values. So when x is 2, y is 2 squared, or 4. When x is 1, y is 1 squared, or 1. When x is 0, y is 0 squared, or 0. And now with these next ones, on that last test, there were some people who made some careless sign errors. Please realize when I'm subtracting a negative number for x, I put parentheses around it because it's that negative number that's being squared. And when I square a negative, I get a positive. There are a lot of people looking at the results that they got on that last test that forgot when you square a negative, if you're using a calculator, put parentheses around it. When we square a negative number, a negative times a negative is positive. And so then over here, -2 squared would be +4. So I'm going to draw myself a set of axes. X. Whoops, I want the y to go down lower. You know what? I apologize. I'm going to redraw those. That'll be my y. That'll be my x. Right now, x, we're only going to 2 and -2. Y, we need to go up to 4, then a little bit higher. And I'm going to go in the negative direction also. So my points are 2, 4, 1, 1, 0, 0, -1, 1, -2, 4. And I get this parabola. And so this is my f of x. And as I look at it, does everybody see that the vertex, the turning point, is the origin, 0, 0. And the axis of symmetry, that bold line up the middle, is the y-axis, which would be the line x equals 0. Is everybody all right with that one? If so, next I'd like to look at f of x equals x squared plus 2. And I want to use those same x values from 2 to -2. This time, though, I'm saying y is equal to x squared plus 2. So when x is 2, y is 2 squared plus 2, which would give me 6. When x is 1, y is 1 squared plus 2, which gives me 3. At 0, y is 0 squared plus 2, or 2. When x is -1, I apologize, I lost my negative sign. Y is -1 squared plus 2, or 3. And when x is -2, y is -2 squared, which would be 4, plus 2 is 6. And so if I look at this, plotting these points, I have 2, 6, 1, 3, 0, 2, -1, 3, -2, 6. And when I play dot to dot and connect them, I'm sorry, I should not have called this one f of x. I should have given it another name. I'll call this one g of x. Do you see how it has that same shape? And all we did was we moved it up 2. As I look at that graph, do you see how the vertex is 0, 2, and the axis of symmetry is still that line x equals 0. But by adding 2, I had the net effect of taking this graph and moving it up 2. So I'm going to add a page and say if I look at the graph of f of x, compared to that, the graph of f of x plus some number a moves the graph up a. If a were negative, it would be going down. Next, I'll change color. Let's look at h of x being x plus 2 in parentheses square. What happens if I add the 2 to the x value instead of outside the parentheses? So here, my x values, let's start with the 2, 1, 0, -1, -2. And I'm going to add one more on the negative side, -3. So to each of those numbers, I'll add 2 and square them to find my y. 2 plus 2 squared, that's 4 squared, which would be 16. 1 plus 2 squared would be 3 squared, or 9. 0 plus 2 squared would be 2 squared, or 4. -1 plus 2 squared would be 1 squared, or 1. -2 plus 2 squared would be 2 squared, or 0. And that extra value, -3 plus 2 squared, would be -1 squared, or 1. And so this time, when I go to graph those points, I've got -3, 1, -2, 0, -1, 1, 0, 4, 1, 9, and beyond that, I'm past my axes. And if I compare this blue graph for h of x to that black graph, the original one, f of x, you see what happened was I took that whole shape and I just moved it to the left. Moving it to the left, the vertex is -2, 0, and the axis of symmetry is now the line x equals -2. I'm sorry, this red one, the axis was not x equals 2, it was x equals 0. I apologize. Goes right through. And so if I look at the graph of f of x plus a in parentheses, it moves it left a. And if I had f of x minus a, then it would move it right a. I'd like to look at two more. Next, let's look at g of x equals the negative of x squared. And that negative sign, there's no parentheses there. So we're going to square and then negate it. For x, if I again use my 2 to -2, I'm looking at the negative of x squared to get y. The negative of 2 squared would be -4. The negative of 1 squared would be -1. The negative of 0 squared would still be 0. The negative of -1 squared, well, this is 1. And when I negate it, I get -1. And likewise, negative of -2 squared, well, this would be 4. And so when I negate it, I get -4. And so if I try to take those values and graph them, I have -2, -4, -1, -1, 0, 0, 1, -1, 2, -4. And if I compare this green one, g of x, to the original black one, you see how it's the same shape, but instead we flipped it over the x-axis. And so if I have the negative of f of x, what I do is I flip it over the x-axis. And one last one. Oh, I did G already. Oh, well. Let's look at, I want to do a different color. I guess I'll use the gray. J of x equals 2x squared. What happens if instead of adding or subtracting the 2, I multiply by it? Again, for x, I'm going to go from 2 to -2. And I'm going to take 2 times x squared to get y. And remember your order of operations. We would square first and then double it. So 2 times 2 squared would be 8. 2 times 1 squared would be 2. 2 times 0 squared would be 0. 2 times -1 squared would be 2. And 2 times -2 squared, that's 2 times 4, or 8. And so here, if I add one more thing to this sloppy graph, I've got -2, 8, -1, 2, 0, 0, 1, 2, 2, 8. And you see what I've done to that original graph is I've stretched it out. I've made it taller and thinner. And so if I look at a times f of x, it's a stretch if the absolute value of a is bigger than 1, and it'll be a shrink if a is a number between 0 and 1. For example, if I took a half, instead of going twice as far, I'd only go half the distance. And so I get a shrink. And so putting all of those pieces together, if I look at what's called the vertex form, of a quadratic function, I'm going to have something of the form f of x equals a times x minus h squared plus k. And with this, if it's in this form, my vertex, let's see, if I'm subtracting, I'm moving right. And then if I'm adding at the end, I'm moving up. So instead of having a vertex of 0, 0, okay. My axis of symmetry is always a vertical line that goes through the vertex. And if it's a vertical line, its equation will be of the form x equals, and it has to equal that value that we go through. Now, if a is positive, I think of it as a happy upward. And if it opens upward, the vertex is the lowest point or a minimum. And like we saw before when we were graphing, if a is negative or less than 0, it opens downward. I think of that as a grumpy parabola. And so if a is negative, it opens downward. And my vertex turns out to be the high point or the maximum. And so just like if a circle was in that center radius form, we got all of our information by looking. If a parabola is in this vertex form, we'll get most of our information by looking. So to graph f of x equals a times x minus h squared plus k. The first thing that we're going to do is we're going to find the vertex, which again is hk. And realize this is a little bit different than a circle, because here h will have the opposite sign and k will have the same sign. Then we'll determine the direction. Again, if a is positive, it'll be happy and open upwards. And if A is negative, less than 0, it'll be grumpy and open downwards. When we determine the direction, we'll decide if we have a maximum or a minimum. Then we'll sketch our axis of symmetry. But from this information, I can get the sense of the direction. I can find the turning point. But to get an idea of the exact shape of the parabola, I need other points. And so for those other points, what we're going to do is we're going to sketch our intercepts. And remember, for the intercepts, for the y-intercept, we substitute x equals 0 and solve for y. And for the x-intercepts, we substitute y equals 0 and solve for x. So we spent a lot of time developing the theory, the idea behind all of this. If everybody's ready, I'd like to go ahead and look at a couple of examples. Let's make sure we can get at least one example done today. Does anybody need more time? Or are we ready? Hearing no concerns. For our example, let's sketch f of x equals -2 times x plus 3 . Hey, sorry about that. My computer didn't shut down. Zoom just gave me the boot. Did you guys get through starting the example? I don't think I lost you until the very end. Could you hear me the whole time or not? Can you hear me now?
We just saw you write example and that was it.
Okay, beautiful, because that's all I did pretty much. So let me share my screen again. And so I wrote the example. And then after I wrote the example, I just drew my axes. So we have this f of x equals -2 times x plus 3 quantity squared plus 8. I'm going to rewrite it over here. we want to compare that to our general vertex form. F of x equals a times x minus h squared plus k. Comparing, does everybody see that a is -2, h would be -3, and k would be 8. And so my vertex hk is -3, 8. So my turning point is -3, 8. And that's my vertex. And it's going. So it's going to be going down from here, which means that, can you guys still hear me? Can you guys hear me?
I'm still here.
Okay. Something just popped up on the screen that said that my internet was unstable. So I wanted to make sure I wasn't in the process of losing you. And so that tells me that that h is going to be the highest point or the maximum. Now, if that 8 is the highest point and this thing's going to be opening downward, does it make sense that my range, my y values, will be everything below 8, -8 to infinity? I'm sorry, -infinity to 8. My axis of symmetry, my fold line has to go through that vertex. And so it's going to be the line x equals -3. And so we have a reasonable idea as to what this thing looks like, but we need more points. For the y-intercept, where it crosses the y-axis, we're going to say what happens if x equals 0. F of 0 would be -2 times 0 plus 3 squared plus 8. So that would be -18 plus 8, or -10. And so this thing is going to cross the y-axis at -10. And because we've got this fold line, we're going to have a mirror image point the other side of the axis. And then let's look for 2 more points. Let's look for our x-intercepts. And they occur when y equals 0, or when f of x equals 0, which gives me 0 equals -2 times x plus 3 squared plus 8. And in order to solve this, being it's in that form, let's go through and try to use that square root property. I'll subtract 8 from both sides, giving me -8 equals -2 times x plus 3 squared. I'll divide by -2. to get 4 equals x plus 3 squared. And then, using the square root property, I'll take the square root of both sides. But remember that 4 has 2 roots, a positive and negative. So that'll give me 2 equals x plus 3, or negative 2 equals x plus 3. Solving here, the first one, I'll get x equals negative 1 by subtracting 3. Second one, when I subtract 3 from both sides, I'll get x equals negative 5. So going back to my graph, I cross the x-axis at negative 1 and at negative 5. And notice that they would be equally spaced around that axis of symmetry. And now that I've got all those points, I can connect them to get my quadratic function. Our range, because 8 was the maximum, was a high point. I know that my range is everything less than or equal to 8. The other thing that you might be asked for is the domain. And because there's no radicals in the function, because there's no fractions in the function, this is going to be defined for all real numbers, though its arrowheads going left and right tell me so. So the domain would be everything in interval notation from negative infinity to infinity, or all real numbers. And so please notice, outside of finding those intercepts, everything else that was important when my equation was in this form, I could get by looking. I can get the vertex from H and K. I can get the direction from A. Knowing the vertex and the direction, I can find the range. I'll know the domain. If it's opening downward from a point above the x-axis, when I find the intercepts, it makes sense that I should cross that x-axis twice, and that I should only cross that y-axis once. I want to do a couple more of these, but obviously we've run out of time again. Does anybody have any questions before I stop class? And before anybody leaves, please remember, if you got in a little bit late, I need to add you to the attendance. Are there any questions? And I apologize that my internet is unstable today and I lost you guys for a minute. Are we good?
Yeah, I'm good.
Hey, did you
Yeah.
get me?
Michael, I believe I got you. Everybody have a great holiday weekend. If you celebrate Easter, enjoy it. If not, enjoy having this long weekend over the spring. We'll see you. Michael, I did get you.
Okay. We don't have
We're
class
off.
Friday?
We're off Friday.
We're off Friday
Oh, okay.
because Sunday is Easter. That makes Friday Good Friday. And if you're of the ilk that you observe those days, it's kind of like a very pious day. And so going back to ancient times, you know, the college has always been closed on Good Friday.
Okay, thank you.
Okay. Have a great long weekend.
Got a question. I don't remember if you remember. I won't be here the following week. I was going to try to get ahead of the work.
Okay. What we did today is almost everything that we're going to do with parabolas. We just have to look at the ax squared plus bx plus c form, but you should be able to do about half of the homework of 3.1.
Yeah, I'm not going to have internet access next week.
Okay. All right. So when you come back, let's try to come up with a mutually agreeable time. Or actually, here's another question. Do you have a class tomorrow at 9?
No.
Are you?
Yes.
Yes. Okay. because my other section, my Tuesday, Thursday section, just because they meet less often, they've done this. And so they're going to be doing those next couple steps tomorrow. And so I was going to say, if you could join in that class, you could kind of get a preview as to what you're going to miss. If you have 10 minutes, go ahead.
I can join after 10.
Okay, all right.